So like I said, those are our three big terms. Today we're going to focus on properties and simplifying. Over the next couple of days, we're going to add, subtract, multiply, and divide. So in order to be able to add, subtract, multiply, divide, as well as to simplify, we need to have certain properties of those exponents. So the first property is a product of powers. So what that means is if you have the same variable, so we'll say we have variable x times x, but each of those x's are raised to a power. So we'll say that the first x is raised to a, the second x is raised to b. X to the a times x to the b becomes x to the a plus b. Not a times b, but a plus b. So x to the a times x to the b is equal to x to the a plus b. So, for example, if I had 3 cubed times 3 squared, that becomes 3 to the 3 plus 2, or 3 to the 5th. If I had p to the 4th times p to the 2nd, that becomes p to the 6th. A quotient of powers says that if you have x over x, where this is your m and this is n, a quotient of powers becomes subtraction. So it's x m minus n. It is top minus bottom. So if you had numbers versus letters again, 9 cubed over 9 squared would become 9, 3 minus 2, or 9. If you had b to, let's say, the 8 over b to the 4th, it would become 8 minus 4, or b to the 4th. Negative exponents are a no-no. Negative exponents are a no-no. So if you had a negative exponent, so let's say we had y to the negative a, then we would rewrite that as 1 over y, and then a becomes positive. You could also have the reverse of that. So if I had 1 over y, and this was to the negative b, then that is equal to y to the positive b. So if you have a negative in the bottom, you can bring it up to the top as a positive. If it's a negative in the top, you bring it down as a positive. So 3 to the negative 8 is really 1 over 3 to the 8. 1 over n to the negative 3 is really the same as n cubed. A power to a power gets multiplied. A power to a power gets multiplied. So if you had x to the a, b becomes x to the ab. Becomes x to the a times b. So again, 3 squared cubed becomes 3 to the 6th. A power to a power becomes multiplied. A variable to a power also becomes multiplied. A positive times a negative becomes a negative, and then you would have to get rid of the negative exponent and bring it down. So eventually all of these parts are going to start working together. A power of a product is different. Now that's xy inside raised to a outside. So a power of a product becomes each variable raised to that power individually. So an outside power goes to everything inside. The same would hold true if the inside consisted of numbers and letters. So that 2 also gets raised to the 4th. So it'd be 2 to the 4th, k to the 4th, n to the 4th. We don't want to leave a number as to a power, so eventually you would take 2 times 2 times 2 times 2 and say that that's really 16 k to the 4 n. Similarly, a power of a quotient works in the same way. So if I had m divided by n raised to the b, then that's really like mb over mn. So that power goes to both terms inside as well. If we have, let's say, x over y raised to the negative b. So if you have an example where it's raised to a negative, then there's the trick where you flip the letters inside and change the sign to a positive. So you flip the inside, change the power to a positive, because that goes back to your negative exponent rule. Then you distribute the power. It should be. I just think my board and me don't get along sometimes. Thank you. Sorry. Now, my favorite rule, and it's like the one we forget most often, is anything to the 0 power is not 0, it is 1. Anything to the 0 power is 1. Anything to the 0 power is 1. Both variables and numbers. Both for variables and numbers. So what we're going to do is take all of those properties and apply them to problems. As we're applying them to problems, there are a couple of things we want to check mark off to know we're done. So the monomial expression is simplified when there are no powers to powers. Meaning you get rid of the parentheses. So that means you get rid of the parentheses. I'll try on this one. There we go. Parentheses. Parentheses. I definitely. That's my Ariana bag. Okay. Each variable appears only once. Each variable appears exactly once. AKA combine like terms. All fractions are in simplest form. All fractions are in simplest form. That means both numbers and variables. And the big one, there are no negative exponents. So there are a couple ways you can get started with each of these problems. You can multiply like terms together. So if I have a to the negative 3 times a squared, then that means I add my exponents together. So that becomes a to the negative 3 plus 2. B and C have no friends. So b to the 4th is going to stay, but anything with a negative exponent drops down. So I would drop down my C, and you don't have to write in that C to the 1. Anytime you don't have an exponent, it's implied it's 2 equal. Negative 3 plus 2 is going to equal negative 1. So I end up with a to the negative 1, b to the 4th over c. Once again, I can't have that negative exponent, so it's going to drop down. So I have b4 ac. If you have a fraction of exponents, it's taught my minus bottom. So that's n2 minus 10, which is negative 8. So again, you have that negative exponent, so we drop it down as a positive. So top minus bottom, negative drops down. And then in 3, we have a whole lot of stuff happening. We have an outside power. That 2 is going to go to every term, both on top and bottom. So with the variable, that creates a power to a power. We know that powers to powers are multiplied. So I get 36r to the 4th over 9s to the 6th. All my variables are similar. However, 36 divides by 9 to become 4. So we're going to simplify the number fraction to give me 4r to the 4th over s to the 6th. The last thing we're going to talk about is something a polynomial? A polynomial is anything that has a whole number exponent, contains no division by a variable. So is it a polynomial if you're dividing by x? No. Is it a polynomial that is raised or inside a radical? No. And then it cannot have, like I said, you can also, so a square root is considered like a fraction power. So like it cannot have like a fraction power. So you could not have, like an example of a 9 would be like x to the 3 halves. Like that's not a polynomial because that's a fraction power. The degree is the highest binomial term in a function. So we have what we call ascending and descending degree. So ascending is when the degrees go from small to big. Descending is when you order the degrees big to small. So in your homework, some of the problems, you have to put them in ascending or descending degree. And then we have to determine if it is a polynomial. If it is, what is its degree? So number 1, not a polynomial. And the reason why is you have the square root of c. Number 2 is a polynomial. The degree of a constant is 0, so this term's degree is 3. 0 to 7. So this term's degree is 9. So it is a polynomial. So it's a polynomial of degree 9. Now Number 3 is sort of a trick. Number 3 is not a polynomial. Because if you were to rewrite this without negative exponents, using our new rules, you have 3 divided by x, which is division of a variable, which makes it not a polynomial. It's not a polynomial if you don't state the degree. The homework is the front and the back of the next page in